Good day. Our topic is about logarithmic and exponential function. Application in science. So the exponential and the logarithmic function can be applied in science, in physics, chemistry, and biology. So we have the first one of the application of the logarithmic and exponential. So I have application in chemistry. So the pH or the meaning of the pH is the measure of the acidity or alkalinity of a substance is based on logarithmic scale. So let's now discuss the relationship between pH and hydrogen ion. Concentration is given by the formula of the pH is equals to negative log H plus. So we will have the problem for pH scale in using and applying the logarithmic and exponential function. So we will have the letter A. Let's read. Calculate the pH if the concentration of hydrogen ion is 0.0001 mole per liter. So to solve the hydrogen ion, let's now have the formula for the pH scale. And we know the formula is pH is equals to negative log H plus. So the first step is we're gonna substitute the value for H plus. So we know that the value of H plus is 0.0001 mole per liter. So we will have pH is equals to negative log times 0.0001. Then evaluate the log and we will have 4. So this is the answer. So for the letter B, you can read the pH of lemon juice is 2. Calculate the hydrogen ion concentration. So just like what we do in the letter B, let's have the formula for pH. This is the formula for pH. pH is equals to negative log H plus. So to calculate the hydrogen ion concentration in lemon juice, we will substitute the value for the pH, and we know that the value for the pH is 2. So we will substitute 2 is equals to negative log H plus. Then we will have negative 2 is equals to log H plus. And the next step is to rewrite the equation in exponential form. So we will have 10 raised to negative 2 is equals to H plus. And the last step is we will evaluate the negative exponent to determine H plus or hydrogen ion concentration. So the final answer will be 0.01 is equals to H plus. Then, so for our conclusion, the concentration of hydrogen ion is 0.01 mole per liter. In the conclusion, for our letter B, Let's go back to our letter B. So our conclusion for letter A is the pH of liquid. Sorry for forgot the conclusion. So the pH of the liquid is 4. And our conclusion for B, this is A and this is B. Our conclusion for letter B is the concentration of hydrogen ion is 0.01 mole per liter. And this is the result. So for our letter C, we have the problem of if the hydrogen ion concentration is a measure of a strength of an acid, how much stronger is an acid with pH 1.6 than acid with pH 2.5? So for our first step, let's rewrite again the formula for pH, and we know that the formula for pH is equals to negative log H plus, where P is negative log and H is H plus. So first step we're gonna do is to calculate the hydrogen ion concentrations of both solutions and substitute the given pH values into the equation. So we will have, we will have 1.6 is equals to negative log H plus and 2.5 is equals to negative log H plus. So for our next step, we will express both equation in exponential form and evaluate. So we will have 10 raised to negative 1.6 is equals to H plus. And 10 is equals to this one, 2.5 is equals to H plus. So evaluate, we will have 0.0251 is equals to H plus. And the T and the 10 over raised to negative 2.5 is equals to 0.0032 is equals to H plus. So for our last step, we will divide the concentration of the first acid and the second acid to find the relative strength of the acids. So we will have 0.025 over 0.0032 is equals to 7.84. And this is the conclusion. We have the conclusion for this one is an acid with pH 1.6 is about 7.8 times stronger with than an acid with pH 2.5. So this is our conclusion. So for the next application of the logarithmic and the exponential function in science or in physics, chemistry, and or biology, you will have the Richter scale. So the Richter scale used to in logarithm to compare intensity of earthquakes. So we will have the table for this one. So you can see that we have the true intensity and the Richter scale magnitude, wherein 10 raised to 1 is equals to log base 10 of 10 raised to 1 is equals to 1. So we have also the 10 raised to 4. In Richter scale magnitude, we will have log base 10 of 10 raised to 4 is equals to 4. So for the last true intensity, we will have 10 raised to 5.8. As in the Richter scale magnitude, we will have the log base 10 of 10 raised to 5.8 is equals to 5.8. So, so an earthquake of magnitude 2 is actually 10 times more than intense than earthquake of magnitude 1. So the difference between the magnitudes of 2 and can be used to determine the difference in intensity. So if the average earthquake measures of 4.5 on the Richter scale, we have 4.5, then how much more intense an earthquake for measures? So that's our problem. So if the average earthquake is measures 4.5 on the Richter scale, how much more intense is an earthquake that measures 8? So okay. So for our solution, we will have the formula of the Richter scale applying logarithmic and exponential function. The first step is let's write first 10 raised to 8 is equals to 10 raised to 4.5 is equals to, so we will calculate the quotient between the intensity. So we will have 10 raised to 8 minus 4.5. So since the Richter scale is logarithmic, each step on a scale is a power of 10. So the difference in intensity is calculated by evaluating 10 to the power of 3.5. So we will have an equal of 10 raised to 3.5. And to evaluate this one, we will have the 3162 or 3162.3. So, in conclusion, an earthquake that measures 8 on the Richter scale is about 3,162 times more intense than an earthquake that measure in 4.5. So, that's all, and thank you for watching.